I'll quickly introduce myself first. I'm David. I'm from SBI R3 Japan. So I joined the company about a year ago. I joined in October 2019. And before I joined SBI R3 Japan, I was I've been working in the gaming and web development industry as a software engineer for a long time. And so I'm quite new in the fintech space actually. At SBI R3 Japan, I am working as a software engineer as well. I'm providing professional consultation services for our customers in Japan. We also provide technical supports for them. So that's what I've been doing in the past year. And so today I'm going to do some technical updates on Corda. And so our presentation is going to split into two parts. I will go over the features in Corda 4.5. And in the second part of the presentation, my colleague Alessandro is going to present the new features introduced in the latest version of Corda, which is 4.6. So this is the agenda today, I will give a quick introduction of SBI R3 Japan. And I'm not sure how many people here are familiar with Corda. So I'm also gonna give a very brief introduction of Corda. It's an overly simplified introduction, but hopefully will give everyone a very rough idea what Corda is and what it can do. The last part will be the main topic of my presentation is the features in Corda 4.5. So about SBI R3 Japan. So SBI R3 Japan is originally a joint venture between SBI Holdings and R3. Recently, we got a new investment from SMBC, which is a Sumitomo Mitsubishi financial group company. So now we have like three shareholders of the companies, and so our main goal and mission is to promote Corda in the Japanese market and to help the Japanese businesses or companies to adopt to the Corda technologies. And next is a quick introduction of the Corda itself. So Corda is a distributed ledger technology. It was developed by R3, and a lot of people will refer it as a blockchain platform, but in some strictive senses, it's not really a blockchain, but it's more like a distributed ledger technology. And it was designed with financial businesses, financial institution in mind. And so a lot of features in Corda are actually designed with that kind of considerations in the financial business. In the Corda, so is a distributed ledger technology. So there's networks. So in the networks, usually the participants of the networks are represented by nodes. Usually can be represented by a machine on the network, server on the network, and so on. And another key feature of Corda is the identity of the nodes or participants on the networks are well known. So meaning that when a node transacts with another node, the node can be sure that the other node or the counterparty is a well-known identity. So that kind of is different from a lot of blockchain platforms out there. So it's more suitable for in a financial business context that you need more trust on who you are dealing with. And another key feature of Corda is that when you do a transaction, instead of broadcasting the transaction to everyone in the network, only the parties that need to know about this transaction will know about this transaction. So it means that there's a higher level of privacy in Corda, and another benefit that you can get by this type of design is that performance, because you don't need to involve everyone in the networks. So that means processing the transactions can be done faster, and it will make it easier to scale when you have a large number of nodes in the network, for example. So Corda is, it comes in open source. So it comes in open source. It also has a enterprise version. It's called Corda Enterprise. So open source, of course, is public to everyone. And the Corda Enterprise is a license-based version. You have to have a license with get a license from R3 to use it. And Corda Enterprise comes with more security features and a lot of tools that you can use to deploy a more production-ready network. So last,
one question that we
yes.
should address right now, is it goes into the fundamentals. The question is simply, what's the difference between DLT and blockchain?
So the difference between, blockchain is that when you need to reach a consensus of a transaction, you need to involve everyone in the network. And of course, DLT and blockchain, including Corda, share some of the common, characteristics in common. So, for example, in both DLT and blockchain, when you have a transaction that is committed, it cannot be reverted. But the difference is that the DLT means that the records of transactions are distributed. But in the way to reach a consensus within the network, the approach is different. So like I mentioned before, in Corda, for example, you don't need to broadcast the transactions. You don't need everybody to know about the transaction. So that's one of the primary differences between DLT and blockchain. Good. So the last point about about Corda is that Corda is written in Kotlin, but it's compatible. So when you want to develop for Corda, you can use any Java, JVM compatible languages like Java. So it should be pretty easy for a lot of developers out there to start the development with Corda. So I'm also prepared some of the slides, but because of the time constraint, I'm not going to go into details of it. But this chart sort of kind of shows what I meant by when you do a transaction, only the people need to know will know about the transaction. So here, each number represents a transactions. So we have 1, 2, 3, 4, 5, up to 9 here. And we had several parties here. And so a good example is that, for example, when Alice and Bob are doing transaction number 1, only Alice and Bob will have the record of transaction number 1. And so the rest of the network, Carl and Demi, they wouldn't know, they will have no idea about that transactions. So that's that hopefully will help everyone understand what I meant by this feature in Corda. Another way of looking at, so this is a graph that shows the transactions in transaction models in Corda. So Corda, basically, when you do a transactions, it basically takes 0 or more input, and then will generate 0 or more output. So here is an example that you have a transaction 1, for example, it takes 2 inputs here, and it would generate 2 outputs. And these outputs can later on be used as inputs of future transactions. So in that way, eventually for data states, you will have a history of transactions that are linked together. And so in that part, that is also something Corda is similar to what blockchain does. So hopefully this will help everyone have a better idea what Corda is. And so next I'm going to
David, another question, if
yes,
I may
sure.
interrupt. In that transaction model that you described, how is that different from other blockchains or DLTs?
How is that different from other blockchains and DLTs? I think in most part it's actually quite similar to other blockchains and DLTs. I'm not sure if it is the same as all the platforms out there, but it's similar to a lot of blockchain and DLTs out there.
Alessandro, do you want to chime in?
If, for example, the transaction model in Corda is the same of Bitcoin, for example. So in Bitcoin, in both Bitcoin and Corda, we use UTXO model, which is the unspent output state. It's different, for example, from Ethereum. Ethereum is a balanced model, an account balance model. So it's a completely different way of thinking about transaction in the blockchain.
Yeah.
Okay, thank you.
Okay. So next I'm going to talk about the features in Corda 4.5. And so compared to the previous versions of Corda, 4.5 introduced some new features in these areas. So I'm going to talk about the features in that did introduce enhancement in the performance and to help it easier to in the development and in deployment and operations. So performance is probably the most important improvements in Corda 4.5. So in 4.5, there is a significant improvement in both the latency and the throughput, which is transactions per second. So it basically means it's faster when you process the transactions in the network, and this is done by a couple of things, a couple of changes in Corda itself. So first one is they reduce the latency it takes for the backchain resolution. So basically, when you process a transactions, when you have to do the resolve the previous transactions, it's improved. So they reduce the latency in that process. Largely by another feature we're going to talk about, which is they can do things in parallel. So which comes to the leads me to the second part of the improvement is that, for example, in Corda, when you process before you commit the transactions, you have to the party that starts the transaction needs to collect the signatures of all the parties involved, and to make sure that, okay, they are all agree with this transaction and think this is okay. So this is a process that we call signature collections and commit of the transactions. So in previous versions, when you have multiple parties, those processes are not done in parallel. So in 4.5, they made the change so that you can do this in parallel when you have to collect signatures and commit the transaction in multiple parties. And another improvement is they introduce is the message compression. So the message exchange between the parties can now be compressed, and so therefore it would reduce the size of the data being transferred. So that is another factor that helps 4.5 to process faster. The last part is the checkpoint. So checkpoint is basically a way for Corda to sort of take a snapshot of the current status of all the transactions, or we call flows going on. In previously, when you have to do this, when you have a transaction with multiple parties, again, it would take multiple checkpoints. But in 4.5, you can do checkpoints you can use one single checkpoint instead of multiple checkpoints. So these are the major changes that Corda did to help improve and optimize the performance. And according to some analysis done by R3, the latency in Corda 4.5 is, it can be reduced up to 13 times. And the throughput, which means the throughput is the transactions per second, can be improved by up to 30% between 4.5 and the previous version. So it's actually a quite significant improvement in 4.5. And so here is a chart. I kind of borrowed it from Quota's documentation, where it shows the latency between the three different versions of Corda. So here you can see we have three lines here, and the x-axis is the number of nodes. So so the number of nodes involved in the transactions, and the y-axis here you have the latency in milliseconds. And as you can see, the orange line at the bottom is Corda 4.5, and on the top is 4.3, and the blue line is 4.4. And 4.5 apparently has a much better performance in terms of the times it takes to process transactions. And this difference is more and more significant when the number of nodes involved. So this is a pretty big deal, especially when you have, if your applications usually needs to do transactions in multiple nodes. So this is a pretty important improvement. And another thing is a throughput. This is similar. The difference is the y-axis is the number of transactions you can process, and again the orange line is 4.5. And as you can see, the number of transactions you can process is noticeably higher than Corda 4.3. So this is probably the most important feature introduced in Corda 4.5. Next, I want to talk about the main feature in terms of development. So this is actually the foundations of the improvement that introduced in performance, which is this is send all and send all map API. So this allows basically when you need to exchange the message with multiple parties, you can do that in parallel. In the previous API, you have to kind of send a message call from the coding perspective, send a message call to in a loop. So you have to do it. You send a message to each party separately, but here you can do that in parallel. And so this also helps the developer a lot. And this feature is also available in Corda open source. So that is development. Next area is deployment. So in deployment, in 4.5, it introduced a official Docker image for Corda Enterprise. So Enterprise comes with a lot of packages, toolings. So those packages are now available in the Docker Hub. And so basically it allows, it makes it easier for developers to, for example, to do automations of deployments of Corda. Okay, so the last part is the operation. So the two important features introduced in Corda 4.5 in operation. So the first area is the data recovery. So as I mentioned previously, that the transactions between two parties are only known by the counterparties involved in the transaction. So in the event of failure or some disaster happen, some party lose their data. Sometimes it can be tricky to recover from the data from from another party, for example. And so Corda introduced in 4.5 introduced two new core apps to help developers to first diagnose if there is any missing data or there's any mismatch of data between you and other parties. And another core app is to recover the data from the other party. And of course, what was recommended by R3 is that this should not be used as the only way that you make sure you can recover data. You should still use some other conventional method, for example, like data backups, to make sure that you can easily recover your data when in the event of failure. So so this is an enhancement in the data recovery, but it doesn't provide the like silver bullet resolution for that. And the other important improvement is the supports in AWS Cloud HSM. So in most of the enterprise Corda applications, you would want to store your, for example, your your keys for your identity or your TSL communications in hardware security module. And in 4.5, they start to support AWS Cloud HSM. So this is actually a good improvement, especially for like in SBI R3 Japan. We have actually worked with a few customers that want to actually use AWS Cloud HSM for that purpose. So this is a good introduction, a good improvement introduced in 4.5. So that's all the features I'm going to cover in Corda 4.5.